Hello everyone, my name is Johanna Rundengan. I am from Study Program Informatics and Computer Engineering Education, and I am part of Group 1. Today, I will be presenting one of the core concepts in programming, conditional logic and branching in Python. This concept is super important because it allows programs to make decisions and react dynamically instead of running in a straight, fixed sequence. Alright, let's jump into the material. Before we start, here are today's objectives. By the end of the lesson, you should understand what conditional logic is, know how to use relational and logical operator, and be able to write if, else statement. And of course, you'll learn to build small programs that can make decisions automatically. What is conditional logic? Conditional logic is basically the decision-making system inside a program. It works by checking whether a condition is true or false. A condition can be anything that compares value, like checking if a number is greater than another, or if a status matches greater text. Based on the result, Python decides which block of code should run. This is what allows programs to respond differently depending on the situation, just like how humans make choices in daily life. On this slide, we have relational operators. These operators allow us to compare two values in Python, and the result will always be either true or false. For example, we can check whether one number is greater than another, or whether two values are equal or not. So something like 5 is greater than 2 is true, and A equals B could be false if the values are different. Relational operators are important because most conditional logic depends on these comparisons. Before using if, else, or else, we need to understand how these operators work. When you start combining multiple conditions, logical operator becomes super useful and requires everything to be true, or just need one to be true while not flips the value. Easy but powerful. Why do programs need branching? Without branching, programs will feel stiff and predictable. With branching, they adapt to situation, input, and user behavior. This is how real-world applications work. These are the three main branching structures in Python. If checks the first condition, else checks addition conditions, and else runs when all previous conditions are false. Simple but essential. Here's a classic example, a grading program. We take input from the user, check each condition from the highest to lowest, and print the grade that matches. This is one of the most common uses of branching. A flowchart helps visualize how branching decisions move. If the condition is true, it goes one way, and if false, it goes the other. This is great for planning your program logic before coding. These are mistakes students often make, especially indentation and missing the colon. Python is very strict about formatting, so be careful with spacing. Next, we have two short exercises to help you apply what we learned today. The first exercise is an age category program. The second exercise is a simple login check where you compare the user input with stored credentials and decide whether access should be granted. These tests are small but very useful because they show how conditional logic and branching are used in real applications. To wrap up today's session, here are the key takeaways. Conditional logic allows a program to think, evaluate situations, and choose different actions based on what the user provides. This is what makes software feel responsive and intelligent. Branching using if, and else is a basic but essential skill, especially when building real-world applications like login systems, grading tools, or anything that requires decision making. The best way to truly understand this concept is through practice. Keep experimenting, keep coding, and keep improving. Code that flows is code that shines. Logic grows when we practice lines. Thanks for learning side by side. See you next session. Enjoy the ride.